Good evening, everyone. It's a nice and bright Saturday evening. It's 4:10 p.m. And we are gathered here for another one of our master classes at the Gifted World community. I'm Dr. Siddharth Bharat. I'm one of the community managers at Gifted World. And we are an online forum for students, teachers, parents, everyone who's looking to develop and nurture talent in their children. Okay. We know that this is often a difficult, a confused journey, and it's often challenging to stay challenged and to stay curious and to find ways to engage. So that's why a bunch of different partners who have been helping talented children for a long time came together to form this community called Gifted World. You can find all of our events and programs on www.giftedworld.org. And we have a free membership that gives you access to interesting sessions like today, and also many, many other opportunities that come up as we grow. We're only 1 month old, and this is our third masterclass in the last 3 weeks. Okay. So without further ado, I will just quickly begin a short presentation that will tell you about Gifted World, and then we will hand over to our speaker for today, who we're very excited about. Okay, so as I said, are you a member yet at Gifted World? If not, I'll send a link in the chat so that you can join the Gifted World online community and get access to many, many interesting things. One of the things that you get access to is we're going to be posting fortnightly challenges. Okay, so last week we posted this challenge and we're extending it for 1 more week. So these are just questions that are going to be coming from different mentors who are part of our group. And I'll post a link in the chat later so you can have a look at it. Do give your answers in the form that's linked at the end of the blog. And the best 3 answers that we get will be featured on our blog next week. Today, I'm excited to be to welcome all of you to a masterclass on the next generation paper plane. This is a masterclass by Rupin Chheda, who's a GenWise mentor and has done several sessions at the Gifted Summer program, the residential program that happens in Manipal. Last year, I had the pleasure of visiting Rupin's class on soft robotics that happened in Manipal, and students had made all kinds of things, ranging from like imitating elephant heads to trying to make devices that move, and lots of really fun things. Rupin is, and the first thing that he did on meeting me was he showed me a puzzle that took me like 2 hours to crack. And I don't think I actually cracked it. I think he told me the answer. So he's an incredibly talented, hands-on person with a lot of diverse knowledge. And so I'm really excited to be hosting him today on Gifted World. And I just want to briefly put some nuts and bolts out of the way before handing over to him. This is the list of prerequisites that we'd like you to have for this session. The paper is the essential one. Pair of scissors, a stapler, pencils will help you. Rubber bands, if you have them, would be great. If you don't have them, it's just something at the end that wouldn't happen. Paper clips are great to have. If you don't have them, you can use the stapler instead. Okay. This is going to be the rough structure of the session. We want all of you to keep your questions and engagement. Don't hold back. However, we are going to stop for questions a couple of times in the session. Okay, so please don't interrupt Rupin when he's in the middle of discussing things. He will indicate when he's open to answering questions, and ideally try and type those questions out in the chat. If not, raise your hand and we will call you at that question time. a request. Let's all please be kind and respectful to each other. We're all meeting for the first time on this online platform, and so let's just speak kindly and respectfully to everyone. So that's it for today. From me for now. I'd like to hand over to Rupin so that he can get started on this masterclass. Again, please switch on your videos so that we can see you and you can see what you're doing. It'll make the session a lot more interactive if you're able to put on your video. Thank you, and over to Rupin.
Hey, Siddharth, thank you so much. Hello, everyone. My name is Rupin, and let me just show you first what I'm making. So this is a plane I'm making. Okay, so it's a huge plane. Are you able to see it? This is made out of thermocol. All right, so I'm yet to fly this. It's not taken its first maiden flight. I'm yet to fly it, so I don't know if it flies, but fingers crossed. So all of you have a pencil with you, right? Yeah, it's not an art. Okay, so quick question. So Rida is typing it out. It's not a glider because it has a motor in it, right? A glider has no motor. You just launch it and it, by that energy, it goes up and down. All right. So first thing that we want to understand, very basic, is you can take your pencil, the pencil that you have, okay, and try and balance it on your finger. Okay. Try and balance it on your finger. At some point in time, you will find it that it doesn't balance everywhere. There is only one, like a tiny spot, sweet spot where it balances. All right. If you shift it little left and right, it will fall down. Right? Everybody's able to do it. So this point on the pencil, is called its center of gravity. Okay, it's the point where it balances. And it's a crucial concept when it comes to airplanes. It's called the center of gravity. Why does it balance? Is on the left of that point where it balances, the total weight is the same as the total weight on the right hand side. So it's like a balance, right? It's like a balance when you go to, say, today actually nobody uses that balance. Everybody uses an electronic weighing machine. But in the older days, or even in if you've seen the statue of the Lady of the Law, which has the uh, uh, a band on her ears, she's holding a balance. Or if you know the sign Libra, so that is also holding a balance. So that's called a weighing balance. If the weight on both sides of the balance is same, it will always be level. That indicates that there is a little bit of a difference between the center of mass and center of gravity. I'll come to that point once we come there. For most objects, the center of mass and center of gravity is close by. It's almost the same. Only when you have a very, very, very big object is when it changes. All right. So everybody, the center of gravity is a crucial concept in what an airplane does. The second question I have, actually not a question, I have an activity for all of you. So what I would like you to do is cut out a strip of paper, this thin. So maybe, maybe 2 knuckles or 1 knuckle thick, and the length of the paper. Just cut it out. I'll wait 2 minutes till you cut it out. You can fold and cut, it's okay. It need not be like accurate, as long as you have like a nice strip of paper. It can be long. So if you see this strip of paper, it is the size of the paper itself that I have, right? You can cut it from this side or this side, it doesn't matter, right? It's okay. As long as like maybe size of my face, if that's a good reference. Okay, we'll give one more minute, and then we can show you. So for folks who already cut the strip of paper, hold it on with your hand like this, pinch it between the two fingers, okay, and let this hang down. Find out a way to lift this up without using your second hand. Okay, so I think Anshita, little bit you figured out. Maybe you're on the right track, little bit, but it has to lift out like straight, like this. Has to be straight, and you have to hold it horizontal. Has to be held like this. Okay, you can't hold it like this. It has to be held like this. There has to be a little bit of a curve in it. And I think James has almost figured out how to do it. Even Arohan, I think, has figured out. I can see him trying out. Let me see others. Aditya is still trying. Arham is, no, not yet. Arham is not done that. Aman is still trying. Pratik is holding it, but I can't see if it's he's. And Vihan is able to do it. Ishan close by. Vihan is doing it the right way. Sonal is doing it the right way. Sanvi is still doing it. Okay, let me just show you how it's done. So you can hold it like this, and you just have to blow on top of the strip of paper. On top, on top, on top, on top. And it rises up. All right. The reason why it rises up is some guy, okay, named Bernoulli, Brnoulli. He discovered that if you have a surface, so this is a surface, yeah, it's called the Bernoulli effect. If you have a surface, right, you can feel this, it's a surface. When air, so there is air on both sides of this surface, right? There's air on top, there's air on bottom. But if the air on top moves faster, okay, when you blow onto it, it's moving faster. It will have lesser pressure just there, okay, just there on top of the paper, there is less pressure, and the air from below pushes it up. When there is less pressure, the air around it tries to fill that pressure such that there is balance all around, and the paper comes in between, and that makes it go up. In a similar way, that's not drag, all right. So this makes the paper rise up. In a similar way, an airplane flies. If you notice this airplane, okay, the shape of the wing, can you see the shape of the wing? Right? It's longer here and it's flat here. Can everybody see it? Right? So when this aeroplane is flying this way, okay, there is air that flows up like this, there's air that goes down. Right? The air that has to go from up has to travel a longer distance because this is a curve, this is straight, right? And that is why it speeds up. And when it speeds up, there is lesser pressure on top of the wing versus the bottom of the wing. This is called an aerofoil. And that is what pushes the plane up. Why? Because there is less pressure here, there is more pressure here. And that is what pushes the wing up. And the wing is tied to the plane, and that is what pushes it up. So, in an airplane, there are four forces. Okay, forces is what pushes things or you can pull things with. That's what a force is. So you have gravitational forces, then you have force due to air. You know, those are the kind of forces that are acting on a plane. So when the plane is flying, there are four forces that act on a plane. The first one is what we just saw, lift. Okay, that is trying to push the airplane up. There is the weight of the airplane that is trying to push the airplane down, right? We have a propeller, right? When you turn this on, it creates thrust, which pulls the aeroplane in this direction, okay, towards the front. And when the aeroplane is actually flying, the air is going to hit the aeroplane, and that is what creates drag. Okay, so the four forces are lift, weight, this one is thrust, this one is drag. Okay, when all forces are balancing each other, so when the lift and the weight balance each other and the thrust and the drag balance each other, the plane starts to fly. When one of the forces is imbalanced, it makes the plane move in that direction. So if the lift is more than the weight, it's going to go up. If the thrust is more than the drag, it's going to go this way. If the weight is more than the lift, the plane is going to come down, right? Can there be more? We'll come to that, how we do it. So that's the challenge that most airplane designers face. Reduce the weight and increase the lift. All right, we'll come to that question in a moment. I think, Siddharth, it's a good time we can address questions before we move on to the next topic that we have.
Sure. So participants, feel free to raise your hand if you have a question in Zoom, if you're aware how to do that.
Okay, Ishan is raising, Vihan is raising.
Go ahead, Ishan.
Yes, sir. So I had a question. Like you said that the top of the wing is longer than the bottom of the wing, right? But why do the two layers of air have to reach at the same time? Because
So it's actually a little complicated way to understand. The simpler way to, I mean, it involves some really hairy math in you have the right question. You are asking, let me rephrase this question. He's saying that the air that comes here, why does it have to meet the air at the back, right? Why can't they go? Why can't both of them just go at their own pace? Is what his question is. Why does the air that go up go faster, and why does the air at the bottom continue at the same speed? Actually, it's a little complicated. There's complicated math around why that happens, but the simpler explanation is that the air essentially has to go faster to catch up.
okay. So
I mean, you can go into the math of doing it, and it's goes into fluid dynamics and a lot of very complicated stuff. But the simpler explanation is it just has to go fast and to catch up.
okay, got it. Thank you.
Thanks. Vihan, would you like to?
So right now you asked a question about like we can change the lift and the weight. That's why according to me there can be like a few fluids or something like gas pressure which can be increased or decreased upon like command so that like on the tip of the plane there is more weight for example and the back is like a bit light so it can maybe result in more lift or like
So what
weight.
he's saying is, Vihan, correct me when I'm wrong. So if you see, this is the back of the plane. If you
Yes
see,
sir.
I can move this,
Yes sir.
right? So this is called the elevator in the airplane. It allows the aeroplane to rise up and down. Okay. This is the rudder of the airplane. Can you see this? It moves. This is the back of the plane. This allows it to steer left and right. In a similar way, Vihan, on this surface of the plane, I don't have them here, but you have something called as ailerons, which allow the plane to do this. Okay, allow the plane to do this. The rudder will allow the plane to do this, but the ailerons will allow it to do this. Okay, so the surface of the wing is not the same every time. Typically in an airplane, the uh, the pilot will have, yes, you're right, ailerons will allow it to roll left and right. Typically in an air, the pilot has the ability to control these surfaces.
Okay, thank you.
Thanks, Vihan. I see a question in the chat from Arohan saying that they recently made a paper plane which on launching started increasing in altitude.
Uh-huh.
Arohan, did you have more to say about that?
Yes, sir. That plane I made, the center of gravity was not close. It was in the middle area. So when I started it, if it was in the front part, it would start dipping down. But since it was the middle, it started doing like this and increasing in altitude. But after a few turns, after crash landing, I couldn't find that same effect with the same plane.
Interesting. So I think what you're saying is you made an airplane and you launched, so you made a paper plane, you launched it. Instead of going straight, you would see that it would rise up like
Yes.
this, right? So you have to consistently rise up. And then what really happens is when the airplane has risen up so much, the only thing it has to do is drop, right? We will cover that. What really happens, that is called a stall. Yeah, Hriday just said that it's called a stall. So once you do this, if you understand the idea of energy that you imparted, so you took the plane, you threw it. So you're using the energy from your hand to throw it. It rises up. All it has now is lost all its speed, because the moment it rises up, it also slows down. The moment it loses speed, it's just going to stall. So the airplane will require a little bit of a speed to continue to fly.
Okay.
Thanks.
We have Hriday who is having a question. And then Eklavya can go next.
Sir, I wanted to ask, what is the difference between the Kawanda effect and the Bernoulli effect?
What effect did you say? Let me just read that up.
The difference between the Bernoulli effect and the Kawanda effect.
So Kwanda. Okay, so I'll just write it down in the chat. So there are two effects. There is Bernoulli effect and Kwanda effect. Okay. Bernoulli effect is what creates in the aeroplane, it creates lift, but the Bernoulli effect's basis is that when air or anything that flows, so let's say water or anything, if it flows faster, the pressure around where it's moving faster is yeah, just quickly, this last question. Pratik, we can just start making. You can actually start making the plane. You just have to make, take your piece of paper. So anybody who wants to start, you can start making the paper plane you know. Don't make the one that I'm making. Any paper plane that you know to fold and make, just make it. Okay, it doesn't matter if it looks the same as mine. It's okay. All paper planes will have the same effect of what I'm talking about. So Bernoulli effect, fluid is passing faster, low pressure around it. Kwanda effect, on the other hand, if let's say you have a basketball or say a football, and if you kick it and it spins, it gets pushed from one side. Okay. Simply because the air on one side is getting dragged, and then there is lesser pressure because of rotation. And on the other side, it's in the different direction. So when the football is moving, air gets grabbed, and that is what, if I can say, Messi does. So when he kicks the ball, it turns in the air and reaches the goalpost. Both of the effects have a similar basis, that there is an imbalance of forces because of the air moving faster. So again, next step is, so we'll pause the Q&A right now, and we'll move on to the next step. As I said, make the paper airplane. Okay, so it can be any that you have, or the goal of your making of the paper airplane is you should fold it really well, and it should be symmetric. When I say symmetric, it means when you are matching edges or when you are matching corners, they should align and arrange perfectly. The better you do this, the better your plane will be. Canard, which is stall proof. Okay. So since you know how to raise the hand, once you finish building your plane, launch it once and see if it goes, if it flies, and then just raise your hand so I know you are done. To move on to the next step after making the plane, it is important that all of us move together and the plane is made for all of us. Okay, Mira's finished. Mira, can we see the plane? Can you just put it up? Like, just show us. Mira's raised her hand. Mira, do you have a question for us? No, okay. Can we see the plane if you're finished? They just done.
Sir, I have not finished the plane, but I just
Uh-huh.
want to ask whether we could also use some other material or let's say tape or something to help make it.
You just have to fold the plane. There's no other material you have to use. Just fold a
Okay.
plane.
Because
That
I don't actually know how to make a folded one. But there is another one that I know, but it needs tape or glue.
Feel free to use it if you want to step away and make it, that's fine.
Okay.
James is done. Pratik, can we see the plane? Can you just bring it up? Yeah, okay. I can see
I
that.
just did the plane
Yeah.
and it eventually worked.
It worked, right? So you tested it out, you threw it. Okay. And we see James throwing his plane around. Anshita, you can also try throwing it if it works. You can step away, try it, and run around. See, James is having the most fun. He threw it at the camera right now.
You can tell what.
It is a boomerang rocket.
Does it go around? It comes back to you.
Yes, sometimes it comes back.
Okay, that's good to know. We'll try and see if we can make that effect better.
Yeah.
Yes.
All right, so how many of us have finished? So let's see.
Please don't lower your hand after you make the plane. So I see like James's hand has gone, other hands have gone down. So keep your hand up if you finished.
That will just give us a sense that how many of us have finished. Okay. Aram's also finished. Shreya is trying. I know Pratik finished. Wow, Mira, we'd like to see that airplane. That is beautiful.
Arham also launched his airplane at the camera once.
I think the best advantage that anybody has is it Sri Krishna. I see him in a car. I assume he's in a car. So Sri Krishna can actually launch faster than all of us because the car is moving. All right, so I think most of us have finished the plane. Now find out, use your pencil, try and find out where is the center of gravity of your plane. Okay, the way you are going to do it is you are going to okay, it's Sri Krishna, that's fine. So you are going to try and balance it. So if you see this, I'm trying to balance it. If I move my finger ahead, it goes behind. If I move my finger back, it moves here. So I want to try and find out at what point it balances. Okay, and I'm going to use a pencil to mark where my thumb was. That is just a reference point where my thumb was. All right. You got to balance the plane. We are trying to bring that concept of center of gravity here. So the plane also has a center of gravity. You want to try and find out where it is. Okay. All right. So once you found that out, the next step that you do is take your paper clip. Okay. Now you know that when you launch it, there is a certain behavior to your plane. You launch it, it does something. The goal of this plane that you've done is that when you fly it, it should go straight. Okay, no left, no right. It should go straight in a straight line and it should glide. Okay, it should glide. The way you can do it is by shifting the center of gravity. Now, I'm not going to tell you which direction you have to shift, but you can use a heavy, like a paper clip. This is a paper clip. And you can put the clip on the plane like this. See this? Okay. Now, what you want to do is you want to experiment with the position of this clip, launch it, see where does it go. Move it ahead, launch it, move it behind, launch it. Not on the wings, just on this body of the plane. Okay. The goal is, what is the goal? The plane should glide. Okay. It shouldn't go this way or this way. It should just go glide. Is the center of gravity the thickest point in the plane? No, not necessarily. Not necessarily. It's the point where if you were to just cut the plane like with a scissor along that line or along that point, and you weigh two parts, they both will have same weight. All right. So now goal, everybody knows the goal. You have to shift the clip right here or here or here or here, wherever you want to, right? The goal is it should glide. Once you know it is gliding, remember that adding the paper clip will shift the center of gravity. Okay, the center of gravity will move. You want to now mark the newer center of gravity. So if you balance it again, you will find that the point has shifted. That is what you want to do. Arham, are you back? I just want to talk to you a little bit because I think you are flying the plane. No, not a dive. A glide is, dive is this. Okay, a glide is this. You don't want it to go this way. You want it to slowly lose altitude. Okay, slowly lose. One more tip, remember if there is a fan running in your room where you are trying to do it, it will have an effect. If the fan is running, it's going to push it down. Try and turn off the fan while you're doing it, because that will change the behavior of the plane. For folks who already marked the center of gravity the second time, the first time you marked without the paper clip, the second time you have to mark is with the paper clip. All right, make sure you do that exercise and keep this airplane on the side. This is your airplane which glides. Okay, this is the first one. If you take this out in an open field and you throw this gently in the direction of the wind, it will go really far. Okay, it will go really far. Because it is gliding, the end goes straight without a paper clip. Very good. But try and see, most paper planes will go straight. It will not go left and right, unless you have messed up in the creation of the plane itself. If it goes straight, gliding will give you the most distance that it travels. Okay, it has to glide. Now, if you throw this in an open field, it should feel like, wow, this is a great plane, because it's taking its time to land. We'll keep this plane aside. This is our first plane that we made. Okay, by shifting the center of gravity, you are able to get a different behavior. For the really curious ones, what would happen if you put the paper clip at the back, like here? Okay, you want to try that out as well. If you put it like here at the very back, what behavior change happens in the plane is what you want to also find out. All right, so these are experiments that you can do with just this plane. Okay, go up and stall immediately. Yeah, probably that is what will happen. It go this way and down. Okay, but it's worthwhile to try it out. We will fold a second plane now. Okay, so the first one, let's have questions. So it is 4:48. Here is how we'll do it. We'll have, say, 2 minutes for newer questions that come in. At 4:51, we should start making the second airplane, and those are the ones where I'll teach you how it can do acrobatics. Okay, so let's have some few questions that we can answer.
Anshita, would you like to unmute yourself and ask your question?
Sir, I was asking, if you don't have a paper clip, how do you perform this experiment?
If you don't have a paper clip, the goal is that you want to add weight at different points. Okay, so first thing that you can do, let's say you have anything that sticks to paper which is slightly heavier. So say blue tack, or say you have any kind of a metal pin, right? So you can poke into the plane and you can change the position of the pin, right? The goal is we want to add weight at different points in the plane to try it out. Okay, so you have to be creative with what you have in your hand to do this experiment.
Okay, sir.
Shreyas, would you like to go next?
So my plane was completed. So whenever the plane lifts up, it keeps on gliding, and I'm not able to find any weight, so I couldn't do anything about it.
Okay, so since you are saying that your plane is gliding without effort, right? So without adding the weight, you are able to make it glide on its own. So don't make the second plane. We'll just modify this plane that you have for the next activity.
Okay.
Okay, so it's 4:50. Maybe we can take one more question before we move on to the second part.
Yeah, Aman, would you like to go?
So Tejas has summarized what really works. So for folks who are still experimenting where to put the paper clip, etc., Tejas in the chat has mentioned that if you put the paper clip right at the front of the plane, that's the best position. Okay, there is no other better position to have it. If you want it to glide like nicely. Okay. All right.
Sri Krishna, did you have a question?
Yeah.
Sri Krishna, we can't hear you. You'll have to unmute yourself. Okay, I think you
Glides without the clip, but can I still? Yeah, you.
Hello?
It's okay. It's okay.
Yeah, Sri
You can
Krishna, we
make the
can hear
second
you
one.
now.
Yeah, yeah. Don't
Sir,
have
I've
fun.
heard of something known as the Magnus effect. I would just like to know what that was.
We'll come to those questions at the very end. I just want to, I mean, because it'll digress us from what we are doing right now.
Sure. Do you want to move on then, Rupin?
Yeah. Okay. So let's move on. Now,
Ishan will come to your question later.
Yeah,
if
we
that's
can
okay.
come to your question later. So if you have time and you can fold your paper plane, again, very good. Okay. If not, we can move on to using the same plane. So I folded the tip and it rolled. Okay, good experiment. Keep doing those experiments, but you have to find out a reason. The reason would be the shift in the center of gravity. If the center of gravity is shifting, then the behavior will change of the airplane. Second, if your plane is damaged, if you see the tip of my plane, because of flying too much, the tip is okay, I'm not happy with it anymore. This could also lead to some changes as you keep flying it. Okay, if you feel like it's not behaving, just fold a new plane. All right, have fun in doing it. All right. Can you see these marks that I have on the wing? Right. Can I have everybody's attention? Can you see these marks? Right. Now, what we want to do is we want to fold the red mark. Like so. Can you see these? Okay. Is everybody able to see it? Can you see this? On the wing of my plane, I have the tip of my wing. I've just folded it little bit. That's the first change we want to do. And the second change we want to do, if you see these black marks, I want to make it so that they fold. I'll just show you what I mean. So I'm going to cut here and here. All right, let me just demonstrate. So I made 4 cuts. You will be able to see I can fold this. Can you see this? Is everybody able to see it? See this. Right? Yeah, these are the changes we have to do in the plane. Now, once you cut it, give it a nice crease. You can fold it either way, it doesn't matter right now. In the experiment, we will keep changing it. So see, this is how my plane looks. Is everybody able to see? Am I turning it around? Are you able to see this? Yeah, let's do this. So use the scissor to make these cuts. It's okay if it is inaccurate. It's okay if it is inaccurate. You will be able to fix it. See, the good thing is it's paper. You can make a new one and keep making until you have it. Okay, don't worry about my plane is gone. It's okay. You can make a second one also. So just like in my plane here, okay, remember that there is this surface. That is what we have cut right now. This is called the elevator. Okay, this is what the elevator is. Right, that is what we have cut. Remember, it can go up and down. It's at the end of the plane and it can go up and down. All right, that is what we have cut. Now, these in an airplane are called control surfaces. Okay, when the airplane is taking off or when it's landing, the pilot has control over these. Unfortunately, we can't control these in mid-flight. So when your plane is flying, we can't control it. But beforehand, you can fold them in a way which gives you some behavior. Now, I'm not going to say what behavior it leads to. I would like all of you to experiment. There are 4 things you can do. Okay. First is both of them are above, like this. Okay. First experiment. Second is both of them are below, like this. All right. You can put them up, or you can put them down. And the other thing you can do is one of them is up, the left one is up, the bottom one, the right one is down, and you can do this. Okay. Now what I want you to do is try experiment and tell me, or just write it down what happened. I did this, the plane went this way. I did this, the plane went this way. I did this, the plane went this way. Okay. All right. Drag is sometimes good. Okay, I'll tell you, drag, not always drag is bad, drag is good. Your plane has an upper wing and a lower wing. Arvan, can you show me your plane? Let me just see. What have you folded? Okay, so you have 2 wings. Wow. So the wing which is the biggest will have the most effect. But again, it's an experiment. So the one that you have folded, it's a good thing. You can experiment putting the surfaces on the upper wing or the lower wing. Again, all of you, whatever I am saying, well beyond that, you can experiment and try out. You know only to make one airplane, right? But if you go on the web, you'll find folding patterns for so many different kinds of airplanes that you can fold yourself, right? And if you keep doing these experiments on those planes, you will know significantly more on how a plane really flies. My plane is gliding like crazy, okay? But Arham, what was the change that you did? Okay, I'll come to that statement. My plane is gliding like crazy. Shreyas is raising his hand. Shreyas, just write your question, what you have, or maybe you can unmute and just ask me a question.
Let me just enable Shreyas to unmute.
Okay.
So basically, whenever after I cut this thing, instead of making it fly, it's just dipping down immediately after flying it. So before, without cutting and folding it properly, it was gliding very well. Now it's like it just goes up and then it crashes.
Okay, so Shreyas has found out one experiment. Shreyas, so what we want to do is, so Hriday is saying it stalls. So Shreyas, the right word for this behavior is called stalling. So it goes up like this, rises, loses speed, stops, and then tuck, like it falls like a rock. So in that case, what I want you to find out is, were the elevators, these two, down or up? Tell me what.
I tried it both ways and both crashed.
Okay, so in that case, can you straighten them out and see if the behavior returns? Like if you straighten them out and then now try flying it. Also, Shreyas, do remember you have taken a paper on which there are crayons. You colored them. Isn't it? That's okay. But remember, if there is drawing on this side and not on this side, there is more weight on this side and less on this, right? Because you have the crayons on this side. It's possible, right? When I fold it down, it stalled almost immediately. So when you fold it down, it stalled almost immediately. Okay, so when you do this, right. But Meera, was that with the paper clip or not with the paper clip? How was it?
It was without the paper clip.
Okay, now try adding the paper clip if you have it.
Okay.
Has anybody tried the alternate one? One of them is down and the other one is up. Yes. Both up, glides, both down, it falls, right up, left down, turns to right, left up, right down. Wow. So Shragvi has actually summarized a lot of the things that she's tried out. We'll come to that once we are just about to end. I think I'm having more fun than just folding the plane itself. Mine does the opposite. Okay. Arhan is like, yeah, I'm gonna make a new one. I'm gonna make a new. He's off.
Pratik, you had a question?
Yes. So my planes goes up and in reverse loop.
Okay, it went up and it did this.
Yeah.
Okay, so it's likely that one of the surfaces you have folded it so much that once it goes, continues to do that. So what I want you to do is I'll explain why all this happens. Okay, why does it turn left? Why does it turn right? Why does it go up? And that will make it clear as to what is happening on the plane. Okay, so everyone, I'm now going to explain the reason why all this happens. Okay, so I want everybody's attention. Can all of you just pause what you're doing and come back to the call? If you are still flying, just come back to the meeting quickly. Is everybody here? Okay, I can see all of us here. All right. So I'm now going to tie all the things that we have learned. All right. I'm going to try all the things that we have learned here. Say I have this pencil. Okay, it is balancing here. What would happen to the tip if I put a force here? It's gonna go up, isn't it? If I put a force here like this, it's gonna go down. Is this not right? Yeah. In a similar way, look at the airplane and look at the pencil. It has a nose, a sharp nose. The moment you fold the elevators down, okay, when you fold the elevators down, when it is moving in the air, everyone, can you pause making your planes for a moment? Vihan, can you stop? Can you just see? Shreyas, can you pay attention? Yeah. The air that is flowing here, can you guys see this? Just pencil. The air that is flowing here hits this elevator. Okay, this elevator, this one. It hits this. Okay, when it hits it, it's gonna push the plane this way. Do you understand what happens? You have the elevator which is pointed down. The air is pushing it here like this. And that's going to tip this. Just like in the pencil, if I hold it at the center of gravity and if I push it from here, this is what happens. Right? That's what the behavior is. If you put it up, the air that is going on top of the plane, it's going to hit the elevator. The effect is you are pushing it from here and that's going to make it rise up. What happens when one of them is down and one of them is up? So the aeroplane on this side sees a force acting up and here it sees a force acting down. So it's going to do that or that. Okay, that is what behavior leads to. It changes the behavior. How does it change the behavior? It will allow the aeroplane to turn like this. Because on one side of the aeroplane, you are pushing it up and one side you are pushing it down. So it will lead to the aeroplane going this way or this way. Okay, so that's the intent of these two surfaces, the elevator. How many of you understood this? Just raise your hand. Yeah, okay. Just say, yeah, I understood this. Perfect. All right. So I think we are at the point where the the things that we had to do with the plane are almost at the end. All right. Let me just go back to where I was. One moment. All right. I'm here. There are a couple more places where you can make these surfaces. All right. So on this wing here also you can make surfaces here. All right. You can do that as well. With the simple airplane now today, let me just quickly summarize what we've done. So we understood the concept of the center of gravity, how it leads to things getting balanced. We looked at the plane, the four forces that act on the plane: lift, drag, thrust, and weight. Then we looked at any paper plane, how do you give it a different behavior by adding weight. So we used the paper clip and we added it here. We had a few questions in between, interesting questions that came okay, let me just summarize this. And then we made one more plane, or you just use the same plane and you made the control surfaces on the wing, which allowed you to change the behavior of the airplane, how it goes left, right, goes up, goes down. Now, using all this knowledge, you can make your airplane behave in a certain way. I will give all of you a challenge. All right. You can try doing that. So if you can find out, say, two loops somewhere, or if you have, say, a parking lot in which you have two parkings, what you want to do is you want your plane to go from one of them and exit from the other one. Okay, that's a challenge I would give to you to do. You have to understand how you're supposed to fold the surfaces so that you throw it, it goes through one and comes out the other. One challenge. The other one is how can you find obstacles where you can find them and try and make your airplane go around the obstacles. Okay, so those are the challenges I would throw to you. And by doing those, you will understand how the surfaces influence your plane. All right. So Siddharth, I think we are at 5:08. We should have some more questions that come in, and then the spiel that you have at the end, the 5-minute one.
Sure, sure. So there are lots of raised hands.
Yeah.
Ishan, your hand had been up from earlier, so if you could share your question.
Yeah. So my question is, like when you take the paper plane and then add the paper clips at the front, right, near the nose, it pushes the center of gravity towards the nose, right?
Yes.
So if it pushes it over there, shouldn't it cause the plane to actually droop down, but it helps in gliding better? Why is that happening?
Why does it help the plane glide better? A plane whose center of gravity is far behind is actually less stable than the one where the center of gravity is much ahead. So Sri Krishna, I think, has an answer. Yes, Sri Krishna, go ahead. You can answer this question.
So in most paper planes, the center of gravity is actually further towards the back. When you shift it towards the front, it actually stabilizes the center of gravity and aligns it with the center of lift, which allows the plane to go much further without having any instabilities.
So Sri Krishna brought in a concept called the center of lift. So that's the point at which if you had to calculate where is the lift generated, it is at that point. So if the center of gravity and the center of lift are close by, almost close to each other, then you have a plane which glides really well. Now I have a question for folks. Let's say you have an actual plane in which you fly, say, from Hyderabad to Mumbai. By moving from the front of the plane to the back of the plane, let's say there are two people who move. will that change the center of gravity? Okay, question to ponder. Are you making the life of the pilot harder? Okay, by moving inside the plane. I'm not looking for an answer right now. It is something to think about. All right. Remember that we had a plane and we moved the weight. Inside the plane, if you are moving, or say the air hostess is moving back and forth, does that make the aeroplane less stable or more stable? Does it make a difference? Does it not make a difference? That's a question. I'm not looking for an answer right now. It is something to think about. All right. Okay. More questions that we can have.
Eklavya, would you like to go ahead?
No, thanks. I think I got my question answered.
Great.
Okay. Thanks, Eklavya.
Okay,
Arham?
so Pratik is saying, can you teach us a way of making a plane? So post this session, what I'll do is I'll send like an image of the sequence of folding. My plane is not really any different. It's just the plane that I know I used to make in school and throw it around from the bus and etc. So that I will send across.
Arham, would you like to ask your question?
Actually, I don't have a question, but I have an answer.
Yeah.
So you said that if someone is moving on the plane, on the real
Huh.
plane,
Huh.
and you said that would it be harder for the pilot?
Huh.
Maybe not, because when compared to the weight of the plane
Plane.
and compared to the weight of the humans, that's actually very less. So it won't cause much of
Much
a
difference.
yeah.
Okay,
won't cause-
Aram, then I have a question. Okay, if you think that the weight of the human is very small as compared to the weight of the airplane, which is true, if the airplane is flying, I'm using up the fuel, right? So
Yeah.
the fuel weight is also going down. Will that make a difference? Again, a question to you. Okay, no answers right now. Think about what is happening in the plane. But the answer is somewhere in the chat. It is given, somebody's given the answer. So you may want to look at the chat and try and figure out. Arohan has a question. Yeah, go ahead, Arohan.
So just now, due to your experiment, I made this plane which has flaps almost on everything. First, the flaps, the winglet have flaps. This part I appraised, so it's also. So this makes. I noticed that this makes the plane fly really fast and glide well.
Right. So what you could do, Arohan, we look forward to you taking like a video of how you made that airplane and sharing it with us. So what we can do is we can give it to the group and all of us can look at your progress, how you did it. So if you feel like this is really good, it's a good breakthrough. Maybe nobody thought of it. Maybe you're the first person thought of it. So it's worthwhile to document it. Like make a nice video, not a nice video, just put your phone on top while you're working on it, put it up on YouTube, share us the link, we'll give it to the group.
Okay, sir.
Were you the one who talked about the individual who made the airplane? You are the one with the book, right?
Yes, sir. I have the book. I got this plane design from the book.
He's the OG of paper airplanes.
Yeah.
Okay, so we have more questions. Hriday, do you have a question? John Collins.
I wanted to tell you that the plane I made over here, so it basically had a lot of weight at the nose, at the tip, and this was very flimsy as it was. So what I did, I just folded up so it has some kind of like overlap, but it's not actually fully folded. So after I did this, I also added a few what do you call? I folded them, the corners. So now if I throw it, it flies like very good. And at the nose, I curved it so it looks a bit like the eagle's beak.
Yeah. Okay, so you've actually taken it to the next level by using origami and bringing it closer to biology. That's how we learned how to make airplanes, right? We looked at birds and we said, okay, birds can fly. What is right about birds? What Okay, they have hollow bones, they have a wing. Earlier versions of an airplane were actually people flapping their wings, but then they realized that it's not going to work, and the evolution of the airplane happened.
Leonardo da Vinci made many designs in which
Models
there were
around it, yeah, designs around it.
people flapping wings.
Yeah. Okay, I think we have space for one more question
We have space for more
before
questions. I mean, unless you want more things to do.
we can actually have more questions.
Yeah. So go ahead, Eklavya.
Sir, actually, I wanted to add to the point that, as you said, it was the actual aeroplane making was inspired by birds. Birds were a part of it, but the wings of the aeroplane are actually inspired by the fins of a shark,
Okay,
which help it to get a better aerodynamic structure.
right.
Okay, thanks.
Yes,
Please don't put my
Krishna,
name
go ahead.
down.
Shwetamri. Give me one moment.
Sorry.
Shwetamri, yes, we are recording this session and we will send it across to all the participants. Folks who joined and folks who couldn't join, both of them.
So I have an answer to the question you gave us regarding the fuel. Usually the fuel is placed in the wings,
On the
so the
wings,
center
yeah,
of
within the wings.
gravity will not change.
Yeah,
And even if fuel from the fuselage tank is used,
yeah.
it's usually not that much because the fuselage tanks are tiny and it's usually just there to help the aircraft maneuver or
In an
change
emergency
the
case.
center of gravity.
Yeah. So what Sri Krishna is saying, just like in the car, the fuel is stored somewhere on the car. On the airplane, the fuel is stored on the wings. The wings are hollow, and the hollow wings are used to store the fuel. So as you start using the fuel, the center of gravity doesn't really change much because you are not moving the weight front and back. You're just moving it. You're reducing it at one point only, so it's not going to change the center of gravity much. Thank you, Shri Krishna. Siddharth, I think
So another thing about the aerofoil.
Go ahead, Shri Krishna.
I think one child told us that the aerofoil's design was inspired by a shark fin. Really, it was just there because people were curious on how to make air flow. But the shark fin thing was only a resemblance because there's not much we really know about the discovery of the aerofoil.
Right.
It was just invented one day, and a person decided to publish
Started
papers
using it.
about it, which the Wright brothers decided
So
to.
your question is the chicken and egg thing. Which came first? Did we discover the
Yes, sir.
aerofoil first, or did we discover that the shark has an aerofoil? Right? Are you saying that?
Yes, but like a shark's like fins are actually symmetrical, while aerofoil actually is like asymmetrical. And
I have
there
a
are different types of
question.
aerofoils.
I have a
There are
question
standard aerofoils. Oh, sorry.
for folks who are fans of Formula One. And when I say Formula One and I say aerofoil, some of you might be able to connect. I'm not looking for an answer, but you must be able to connect how those two are related. Okay, no answers. If you know, well and good. Spoilers.
Yeah.
Right.
So let's go back to asking questions.
Yes.
Vihan, did you have a question?
No, I think he's talking about the spoiler.
I had a question.
Yeah, go ahead, Vihan.
So like right now I was making this while adding the what do we call these?
Elevators.
While adding the elevators,
These are
so I added those over here, but I also added them in the front of the plane.
Yeah.
But sir, what I noticed was like whenever I'm throwing the plane, the back elevators are up and the front elevators are down.
So the ones that you have on the wing, they are not called elevators, they are called ailerons. Ailerons. So they have a different effect to the plane.
So, but whenever I'm interchanging, like for example, right now the ailerons are like down and the elevators are up. But if I rather did that like the elevators are down and the ailerons are up, there's not much of a difference. They're
Not
flowing.
much of a difference. I think then your goal should be that you change the size of them. Make one which is much larger than the other.
Okay, sir.
Yeah. So then it will give you some imbalance that will make sure that you realize, okay, this change, if I do it this way, this is happening. Right now, they are almost canceling each other out, right? So try and make one of them slightly bigger and the other one smaller.
So, but is it dependent on the weight as well? Because like this is approximately 6 centimeters, and this is like 3 only. So it is twice
But it
as well.
might be thinner.
Yes, sir.
So the area might be same.
Okay, sir. Thank you.
Try and increase the area. The right term to say is try and increase the area of one of them. Maybe twice or thrice of it, make it really big. If you feel like the aeroplane is cut too much, make a new one.
Yes, sir.
Shreyas, you had a question?
No, you didn't.
No, you don't have a question. Okay, fine. Thanks, Shreyas. Ishan?
Yes, sir. I had a question. So, when we made the paper plane over here at the sides, we folded these two things, right? Wait, why are these two, like, how are they helping in the aerodynamics?
So what really happens is, once you actually fold these, what they discovered is at the tip of an airplane, if you put, and most airplanes have them today. So these are called, I think I forgot the name of this surface.
Winglets, I think.
So they're
Is
called
there on the
winglets.
chat.
Winglets.
Winglets, yeah, these are called winglets. So when you add those, what really happens is, it improves stability a little bit. Okay, not a lot. This is almost as good as the rudder in the plane, in this plane. Okay, see, the shapes are very different. So they will have two very different behaviors. Um, if the winglet is on this plane, okay, it aids in a little more efficiency in the plane. If you look at the planes that we fly commercially, the planes that fly commercially, they have the winglet. What they discovered is when they added it, they were able to increase the efficiency of the plane, so it uses lesser fuel to travel. In this case, because it is so far behind, it has the net effect of a rudder. So even if you fold this one down, okay, so this is up, this is down, you'll have a different effect to it. I will urge you to experiment and see. But whenever you're experimenting, only change one surface. Because if you change this and this, you'll not be able to judge why it led to it.
Okay. Wait, one more thing. One more thing. Because this is like almost like perpendicular, right, to the
Yeah.
surface of the plane.
Yeah.
If it is in line with the air, then how
Yeah.
is it causing aerodynamic forces that are different?
When your plane tries to tilt, force is acting on it this way,
Okay.
right? So there is this surface, this one, which prevents your plane from going this way, right? But even these will help protect it going this way. If one of them is flat, then see,
the
in
other
my
side.
plane, they are not really horizontal to the direction. So this is the line of the plane, and it's here like this. Okay. In all likelihood, when it's flying, this is gonna push, the air is gonna push it this way, and it's gonna make it tilt this way.
Oh, so it's like a rudder. But
Yeah.
that's
But in your plane, they are both parallel to the center line, right? So maybe if you made a wider plane, like not the one that you had, you'll be able to judge the effect better.
Okay, got it. Thank you.
Thanks. Then I saw.
Yeah. So
Is
Sri
it,
Krishna, yes, it
Anshika?
allows it to reduce drag, right? So when you reduce drag, you are effectively increasing efficiency. But that happens if it is on a wing like a standard airplane. How it behaves on this one is because it is so swept behind. It's so behind. the effect is going to be different than what you just said.
Anshita,
right.
you had a question?
Sir, I was asking, if you cut the plane in half, will it still?
If you cut the plane in half, okay,
Like if you cut it from here,
yeah,
this part and this part separately gonna fly. Can it fly?
why don't you try it out? What happens?
No, it doesn't fly.
It doesn't fly. So if you make a new airplane, I think now this one is cut. We can't do anything about it. So what I would urge you to do is start cutting it from behind until the point it stops flying. So you cut a little here, you cut a little here until it stops flying. And then the marking that you're doing for the center of gravity, try and see how also that changes.
Okay, sir.
Okay. You now cut it from the center, right? So you have two airplanes which are not airplanes.
And sir, I had one more question.
Huh?
That the rubber bands we were gonna launch the aeroplanes with them. How do you launch?
So how do you launch an aeroplane with a rubber band? Okay, so I'm going to show you how. So this is your aeroplane, right? What you can do is you can make a cut here, okay, in which you can put a rubber band. I don't have one here. And then you can pull the rubber band and leave it.
Sir, should you pull the rubber band back or front?
No, front.
Okay, sir.
So you can put the rubber band on the pencil, right? One end of the rubber band on the pencil, and then you can have the other end stuck in the. Wait, let me just cut and show you how we can do it. So you got to make it of this shape.
Okay, sir.
Okay.
Yes, sir.
Once you make it of this shape, the rubber band can be stuck here, okay, in this slot, right? And then you can pull it a little bit. Remember, this is paper, so it's not going to take a lot of force. And then you can leave it. It's going to get launched.
Yes, sir.
Yeah. So that will save you from doing this.
Okay, sir.
Okay, so we have yes,
There's a
Vihan, yes. If you
question from Vihan.
make the plane with broader wings, it's going to be more stable because there is more air below it, and it will require a lot of force to change its direction. So yes, the airplane with a broader wing is going to be more stable than the one which has more shorter wings or more smaller wings.
Great.
Yes,
So,
Siddharth, I think we are
yeah.
at the end of the session.
Yeah. So I'll just take 2 minutes to wrap up and
Sure.
also tell you about future upcoming things from Rupin and other people as well. So I'm just going to share my
Wait, let me just say thank you, everyone. I think this was a great session. I had a lot of fun. I'll still stay around and hear what Siddharth has to say.
Yeah. Where did it go? Sorry, just a minute. Technical issues with Zoom. There you go.
Okay, just before we actually end, I would urge you to find out other designs of paper airplanes on the web. You will find a lot of designs other than the simpler one that have different behaviors. So it's worthwhile to fold them as well and get a hang of how does it fly. Choose, after you try 10, 12, choose your favorite one, practice on it, and keep making that over and over again.
Thank you so much, Rupin. I think one of the really fun things about this session was how you didn't really answer questions. You said, go experiment, go experiment, go experiment.
Yeah.
And
yeah.
that's something that we don't see a lot of in life. So thank you for that. I just briefly want to tell you that upcoming Rupin's actually running a whole 3-week course on an introduction to aero modeling, which is going to happen as part of the gifted summer program in Manipal. It's happening in May. You can visit www.genwise.in for details. So what you saw today is just a teaser of the first day of the course. And people will be going on to do a lot more over there. So if you like today, that might be something that you'd be interested in.
One moment. So quickly, so this is one of the airplanes that everybody's going to build in the course. Okay, so I have built it for my own practice, but the Manipal University has a big ground. So we are going to build this airplane and we are going to fly this airplane. So you're going to learn how to build it and how to pilot it as well.
Wow, that will be fun. If you're interested, you can visit genwise.in for details, or just reach out to us and you can drop a message in the chat and we'll get in touch with you about it if you're interested. So tomorrow we have actually next week we're having a workshop on parenting for talent development by Dr. Bhushan Shukla. I'm actually going to show you these things on our website. So if you go to giftedworld.org, we've got 2 upcoming events that are for mainly geared towards parents. So if your parents are listening on this call, please do tell them. So one is tomorrow, the same summer program that I was telling you that Rupin is doing a session next week. Tomorrow we have a parent hour about it. So this is going to tell you more about what the gifted summer program is like. And then next week on the 24th of February, 2 weeks from now on the 24th of February, there's a workshop on parenting for talent development that we're having an eminent child psychologist, Dr. Bhushan Shukla, who will be teaching us various ways and tips of how to be a more effective parent. Something that I, as a parent of 2 young children, strongly relate to. So we will also have more master classes upcoming. We're still scheduling them. And so the information of that will come out to you on email. And we're really excited that this is how the Gifted World community has had a start. And we're looking forward to many more such interactions. Please keep making your paper planes. Tell us what you've enjoyed, what's worked well. Our email is also on the website. You can reach out to us at info@giftedworld.org. And we will forward your emails to Rupin if that is what you want. And please do stay in touch on the website, and we look forward to building and growing this community together. Thank you so much. I'm happy to answer any questions briefly if people have it. Vihan?
Sir, I have a question about the paper planes only. So, I want to ask about that. Takeoff usually take a lot of fuel to actually go, and takeoffs are itself like a hectic process. Instead of that, right now, sir told us that we can use a rubber band to send the plane. So
Right.
why can't we do that in real life as well? We are actually have launchers that will simply propel the plane up high. Over there, we can turn on the fuel so that it can have a stable ground and then it can start flowing instead of actually doing this.
Right,
We
so
we
there are
actually do it where we have shorter runways, especially on
aircraft carriers.
carriers.
Those carriers.
Right? So fighter carriers, the fighter aircrafts go this way. That's the first reason. I think the second reason is comfort, because if you are sitting in an airplane, you are not like a fighter pilot where you are attuned to flying. You might have elderly, you might have children. I think if you accelerate them that so fast, you might have some uneasy
Yes, sir.
people in the flight. I guess that is the case.
Yes,
I've
sir.
also heard of this being used in drones.
Yes,
So
sir.
some companies that are using drones to do things like that, added acceleration doesn't make a difference. There's no one in it. But it makes a lot of sense that you don't want to waste your drone's fuel on taking off. You instead just launch it.
Yes, sir.
And there are concepts out there. It's not been tried, but there are some people who are building centrifugal launchers for rockets.
Yes, sir.
So you spin it really fast in a centrifuge and then let it go and boom. So it's a concept. I'm sure people are exploring it and funding it, but it's not
Right.
yet in the world. The centrifugal rocket launchers.
Thank you so much.
Yeah, zipline. Thanks, Ishan. I've seen that. Zipline is the one I've seen referring to that. Thanks, Ishan. Shri Krishna, you had your hand up.
So, I've heard of something known as dihedral wings.
Yes, that will
I've
be a
heard
Rupin
about it,
question.
but I'm not exactly sure about it.
Rupin, are you able to tell us anything about dihedral wings? Because I don't know. And only if you have the time. Don't want
I
to
can
keep
tell
you
you
longer.
about dihedral wings. Yes, quickly I can tell you. Wait, I kept my plane away. So essentially, for trainer aircrafts, right? So there are aircrafts that people train on. The wing of an airplane is actually typically straight, if you see. But a dihedral wing, the wings are like this. Okay. Now the reason why they have it this way is, say that your airplane is tilting like this. Assume that it's tilted like this. What really happens in the dihedral wing is the wing which is below tends to have more force acting on it, the part of the wing, and that is what brings it up. So it's a more stable wing. I don't know if I answered that well. So they are in a V shape, and what really happens is the moment the airplane starts to tilt a little, okay, the part of the wing which is lower than the other one suddenly sees a larger force acting on it, and it brings the plane back to a neutral position. You can have wings that are straight, like you can have straight wings, or even in this you can make a dihedral. So you can make this. If you make it like this, your plane would go more stable, so it'll have a more stable flight. You can try it out. You can also make a dihedral in the paper plane. The other opposite of dihedral is anhedral. So you'll have the the wings like this.
Okay. Great. Well, thank you, everyone. I think we'll wrap up for today and close the session off. Thank you, Rupin, for staying extra and answering more questions.
No problem.
We're looking forward to it, and we'll be in touch and see you around again. If you could all unmute yourselves to say bye, that will be great. Like unmute yourselves and turn on your video, and we'll say bye.
Bye, sir. Bye, sir. Thank you.
Okay, see you everyone.
Bye, sir.
Bye.
Bye bye.
Bye, sir. Thank you.
Bye bye.
Bye. Thank you, everyone. See you later. Thank you for coming, James. It was a lot of fun to have our youngest participant ever so far.
Bye, sir. Thank you.
Bye bye. Okay, bye. Thank you, everyone. See you.